All right, Lee.
All right, so this wasn't on the official voting. The theme of this one's going to be, I don't want to sit down for most of it. So talks that we've had kind of offline and during this, the first day of the SIG, we realized that API throttling is API quota, running out of it. Using out the API quota is a pretty big problem with the storage subsystem, in that the node or some other service will chew up the quota long before the storage ever gets a chance to use it, and then attach and detach fails, or other cloud get info calls will fail, and storage ultimately ends up not working, and that's the most visible thing to users. So we get bugs open against storage when it was actually something else further up the food chain that chewed up the quota. So storage is profoundly impacted by API quota, and there's no throttling in place to make sure that different components are using quota using the API respectfully, or not chewing it up when they shouldn't be. Nobody cares about this. I mean, the truth is the top level components chew it up and they're glad to have it, and then by the time that storage takes a dump, they don't care. It's not on them for chewing it up, but we suffer. And so it's kind of on us to champion this issue, I think, up to some of the higher level components and to the cloud providers. Do you want to say anything on this? I mean, I know you have some firsthand experience with it as well.
Yeah, so like in terms of observations, a good example is the external provisioner. The way it works today is if the external provisioner is turned on and there were 100 DVCs that are not bound, it'll create 100 threads immediately and try to watch all of those processes at the same time. And it basically starts getting problem blocked by the Kube API server. So sorry, you're being throttled. And what happens is now attached and detached requests are failing, provisioning requests are failing, and recently the CSI provisioner was updated to support all that, where it goes 1 second, 2 seconds, 4 seconds, 8 seconds, etc. So what happens now is it stops trying, and it basically ends up waiting. These 100 PVCs with these jets would actually be created and bound, or the PVC created and bound with PVCs. 30 minutes to an hour later is what the third observation is. Because of this handle everything at once policy.
Yeah, so it's instead of doing a serial style request, like everything just comes all at once, right? And some of it misses, and if the stuff that makes it through may cause other API requests to kick off, and the stuff that didn't make it through will retry inevitably, and it turns into a big storm of a problem. So the question is anybody interested in this enough to go and champion it to other SIGs? Maybe somebody from Google that would.
Are there any specific action items that we need from other SIGs? It sounds like at least we have a lot of action items on our side to clean up some of our access comments.
I think what we need is either like a single point of access that we can proxy everything through, instead of just letting everything have unfederated access to the cloud provider API. It needs to go through like a single point that can somewhat meter it and provide a serial. Yeah, all of Kubernetes. Like it won't help just us to fix it. Like it needs to come from, Node needs to do stuff to fix their.
Where would you put it in? The AWS cloud provider? I assume we're talking AWS.
There are two different issues.
There are two different issues, right? There's the cloud provider API, and then I think there's an API server quota issue as well. Kube API server. So there's both of those. We need some kind of throttling mechanism for any kind of API access.
Just I'm trying to understand this. Like you have watches, like you request 100 PVC, and then the 100 routines trying to provision. Because each provision happens in a separate group.
Yeah. Okay. So like an example of what Scott was primarily is it opens up this 100 watches, it starts doing things.
Not 100 watches, right? Like 100
notices, 100 threads to do this process of creating all and doing all the tasks required. And what happens is When it goes to create the PV object, they say, yeah, I got back from the CSI driver, the volume to create, I'm gonna go create the PV object and find it. It fails there, and then screws up. And so that gets throttled over and over again to where it doesn't try to redo it for 5 minutes. And sometimes if there's enough things in the queue, it becomes a swarm that is potentially unrecoverable, and it eventually recovers after 30 minutes, an hour, 2 hours before you get to the system.
So does it create a water
I think in these cases, it's just to inject.
So serially, it should be able to do this already, but it's just because it does 1,000, 100 at once, then they have 100 failures or 95 failures that start it up. It screws up the process and it keeps trying. Because some calls go through successfully, and a lot don't. And the calls that are going through successfully are the ones that don't need to go through successfully. They shouldn't be in the queue yet. But they should be in the queue. They shouldn't be taking action on it yet.
So it sounds to me like we need to address those issues. Like we need to make sure our access patterns are smarter. We need to have thread pools that'll limit the number of current requests we make. We need to do a better job on exponential backup in different places. I'd say that would be step one. And
For the
see-
Cube API piece. Is that going through Go Client? Is it Go Client that's ultimately getting throttled?
I believe so. It's coming up with the external version of the CSI. I'm excited.
Okay.
So we start there and see if that's sufficient to get this behavior under control. If it's not, then I guess we would need to escalate to.
Well, you have a similar problem with cloud providers too, right? Like attach detach constantly fails because there's no quota left.
That's definitely another problem. Where
This is on the AWS one.
Any cloud provider, but AWS, we've seen AWS specifically because that's where we run those.
It's a part of open stack also that right? There are too many like you can choose from open stack like for when they have a controller type in that like 1.6 or something when we do the verification of the volumes. So we pull periodically all the volumes in the cluster, check it in really attached.
So it's a problem with all cloud providers, or it's something that we should address it.
Yeah.
I've seen the AWS issue, but it does not appear to be higher level or node consuming the API, the cloud provider API, where it just seems to be, if you are attaching 100 or mounting 100 PDs and you're attaching them to nodes, then it's just work consuming in storage. Because there's not that much going on with the cloud provider in terms of nodes. You're not really adding that VMs or instances, networking.
I think the biggest issue we saw was when we added the code that goes in and lists all the volumes that exist. And for AWS, it was doing like one call per volume. And then I know Jing did a bunch of work around this to try to improve. Instead of doing one call for every AWS, list all volumes, to batch that call. Do you remember all that work, Jing?
Yeah. Yeah, I do that.
Okay.
And we implemented bulk polling. But right now in AWS, primarily for AWS, we don't need it. Just for AWS, we don't need because in AWS you cannot detach a mounted point. AWS specifically
Yeah, but we still have AWS quota issues, API quota issues.
yeah, we have so many AWS.
What's chewing up the quota? I thought it was something other than attach detach.
No, we have right now described volume going to the quota and some described load balancers. Sorry. So
Describe node
load balancers.
balancers?
Load balancers.
Load balancers.
Yeah, described load balancers is right now the one of the points of this, but it's like it's shifting like goal problem.
Yeah,
It
we
keeps
solve the
moving.
issue in one area, it
And
pops up
it
somewhere else.
And then we added an instance cache in AWS where we cache the instance information so that we can try to reuse it and with the TPL and that do some of the problems. And I'm just curious, as we move to the different, how the CSI and external cloud provider and they're all doing their own thing, the instance cache that we have shared inside in code Kubernetes, but obviously it will not be.
Yeah.
So what caused described load balancer?
That was there was a peer open query for fixing that. So that was like it's like so the service doesn't have any load balance. Then call the dispatch runs it's like I think it's related to service catalogs. So I don't understand. We'll open a couple of processes.
Usually there are two quotas, right? There is the quota on how many AWS operations you're issuing. The one that seems to be in the reports more common is that for that particular API, you're taking. So for describe volume or get snapshot of those, each API will have has a quota. That's what we're hitting, and what that points to is like we're either doing the same operation.
Is it like
different, like in parallel for a lot of nodes or instances, or within the same during the same process where it would be operating over?
For AWS, it's like there's a mutable API, like attach volume, create volume, delete volume. These are like mutable. And then there's an immutable API, like describe volume, describe instance. And these two have different quotas. It's not that each operation has a quota. I mean, as far as I know.
They're both.
So Amazon told us that the mutable APIs have different quota and immutable APIs have different quota. Mutable API has much higher quota, and this can have a problem. Like, so the plan for like CSI particularly is we are trying to think if we can use CloudWatch events. So rather than polling it, if we can get events into our processes, so that we can consume the events to check if the volume is really attached, to check if the volume is really attached, rather than polling it every couple of seconds. But that design, like, is a proposal by we're working on.
So it sounds like we have a few issues tied to somewhat related. How can we consolidate this into one thing that we can track better?
It's dependent on the model of quota. So my understanding of the AWS quotas was that they're relatively transient, right? It's the quota. So if you receive one of those errors that say that you should wait 15 seconds, and maybe you should wait 5 seconds. You know, I think the solution should depend on what the model for the quota is.
Well, so AWS tells you wait 15 seconds, so you're the storage attached detached control, and you wait 14 seconds, and then that jerk load balancer comes in and gets the quota call.
Yeah.
Right?
It depends on which quota you're hitting, right? If you're hitting the per request quota or the people.
And there's a throttling implemented in the each. I mean, I don't know if all the other cloud providers implement, but AWS definitely is throttling. And if you are getting the request limit exceeded exception, error, then it backs off by whatever time that AWS starts to back off, and it will not. And all the operations will meanwhile will just get error and type and whenever this throttling thing has expired. So we do that already, but it just results in like poorer user experience, everything, and that's pretty much like
On the same note, this is where it's complicated, is priority for operation. Attach, detach, critical operation, create, delete, not critical operation, create, not that critical. But attach, detach need to have some sort of priority queue, especially detach, because the cleanup stuff is usually really important. So there's got to be, there should be reserve buffer. You don't want to be getting that wait 15 seconds. Because that means now a really important critical operation isn't going to happen.
So can we open bugs against the cloud providers? And is there a way to succinctly describe these problems that puts it off on the AWS and other cloud providers to solve it?
We have to like come up with like action items that we could suggest.
Or reproducible bugs. I mean, I was thinking of taking it from the DDoS standpoint. I mean, could we tight loop some PV operation that shows an expiration of, or that chews up the quota?
Well, my comment on assigning an issue to a cloud provider, now that I'm representing these
we have a cloud provider,
is that that seems fair if that boundary encompasses all aspects of this, because then they can fix it. But if what's going on is the cloud provider's making some API calls, and then over in storage, you're making some too, that doesn't seem like it's going to result in, you're throwing a ticket over the fence, but they're not in any position to fix it.
Well, we're making the calls through the cloud provider, right?
Oh, if you are, I didn't know that was what was going on.
Well, there was two pieces. There's the Cube API itself, which needs to be throttled somehow, and then there's the cloud API that needs to be throttled somehow. And I don't know, I mean, it seems like it's a problem that should be solved for all cloud providers, but we could pick on individual cloud providers and say, hey, we have this bug very specific to AWS.
Just brainstorming, I've done sort of some things like this before, and there are great solutions. You know, you queue them and the things can get old. And the Kubernetes controller pattern makes this somewhat ugly, where you've got control loops going on that are monitoring something and polling if one thing that won't work because of the controller panel is have a background loop goes and gathers this data and caches it, and then you don't get a live reading, you get a potentially stale one. And I think that runs the risk of having a lot of these control loops break all over the place. So I would eliminate that from consideration. But one that's more generic might be to get tickets, to get permission to make API calls. And what Chris brought up of having priority queues, you could have an overall system-wide quota of tickets, but then you have independent loops where if it's high priority, you go to the high priority ticket granter, ticket number, and when you're about to call, if your number is not ready, you can't make the call yet. And that's one way to do it that seems pretty generic, not dependent on any one API, that you could write a piece of code to just grant these permissions to make calls and maybe use that. But that's sort of a big overall architecture picture of all of Kubernetes. So that strikes me as something you might want to prop up all the way to the top level architecture level of Kubernetes before you start making moves to go implement it.
So I think we need somebody outside of SIG storage to help us address this, right? What would be a good path? I mean, I think you Googlers have a little more force into the.
We could start with SIG architecture and just say, hey, here's the problem that we're dealing with. Who suggested?
You guys still there?
Yeah, I can't hear him either. Vlad?
Yeah, they just went silent.
Well, I think it's frozen too, isn't it? I don't see anyone moving.
Yeah, you're right. I'll try to throw something on Slack.
I still don't hear anything. Did reconnecting help?
No, it did not. I just reconnected and it looks like, oh, I hear something now.
Hey, Steve.
I don't know if you can hear us yet.
I don't think you can hear us.
Document. We say there's up to this scale, you won't have a problem after this
Okay.
threshold. And also error back to the user, right? Because I think there's users don't know why the stuff fails. It just says volume failed. And it failed because something else should have been quota or there wasn't enough quota to start with. Okay.
You consume quota if your request fails.
Sorry?
You consume quota if your request fails. I thought it was back up as a quota.
Do you consume quota and the request fails?
I don't think you do.
It's I don't know how it.
Oh, Aaron, the laptop battery died.
I don't think so.
So you get the back off response.
Hot.
that calls on counter against your quota.
Yeah, I just saw something on Slack.
I guess I'm asking how.
Oh, for
how
mutable
the
API, like attached, for example, attached fields. Okay. Yeah. So, I think it depends on how AWS counts it, and what we found out was we would be like, if we wouldn't be checking like if this attach is going to succeed, then one, and like let's say the volume is attached somewhere else, and then we're trying to attach this to a different one, and we are doing this like every 5 seconds. So attack is failing, but it's not failing because of the quota accelerator. It's failing because the volume is attached somewhere else. So it is still being counted towards it. And that's why it's like useful to check, put this, and we put this all the checks in this plugin now, that stuff. But it's like useful to have this. So now that's why we added the cloud provider matrix, so that now we know what is causing this API users. And we didn't have this matrix before, but
So are you happy with this or?
So I was thinking like start simple, because obviously it's not really hard ways. Simple ways to me is like for the external permissioner, these set capture. I can say, hey, don't try to create don't handle more than 5 objects at a time, and there's not a flag, and don't try to create or delete more than say 60 volumes a minute. Simple flag says it's going to handle this, and it's just going to set the boundary that it's not going to be more than that. Same for the pretty easy to set. And the same for attachment detachment. Like the attachment is you say, don't try to attach more of this many at a time. And don't do more of this many print. That just gives end users the ability to set the options and the guardrails so they're not causing problems.
Can we, I mean, is it possible to separate the different CSI pieces into accounts and then have separate quota for each account? And that's the other option, is to have, different accounts for each thing making calls and dictate the priority with that, right? So whatever's making this describe load balancer call could have one account with its own quota, and then we have detach accounts that have its own quota.
I think that gets a lot more challenging, because right now there's a single cloud provider library, and everything goes through that.
It doesn't know different accounts.
Moving forward, all that cloud provider code is getting worked out in separate components. Theoretically, they could have different accounts. Amat actually pointed out something interesting, which is that as we begin to rip stuff out of the core, we're actually going to make this problem worse, because we're going to have, for example, if you have today a single volume, all the volume plugins will share informer that allows them to basically not have to each fetch all the PV objects. But moving forward with CSI, all of them have their own sidecar containers that are fetching PV objects, fetching PVC objects. So you're actually going to be hammering the Cube API at least at a much higher rate. So we're going to make this problem worse before we make that better. But it sounds like the correct approach is going to be to ensure that our access patterns are optimal, make sure we're doing the right things like exponential back off the jitter, make sure we're limiting the number of operations that we start at any given point. So do all the right things there, and then if that's still not sufficient, then we start looking at bigger numbers, whether it be multiple service accounts or even some sort of centralized queuing system, which, like you pointed out, is actually counter to what Kubernetes is about. So we'll have to let's start with the initial steps of let's do the right things, and if that's still not sufficient, we can talk about bigger things.
What about repercussions upstream? 'Cause you might know more than I do about this. But let's suppose that I'm about to deploy a pod that's going to need 3 volume mounts. The right thing to do, if I can tell in advance that I'm going to have to install the volume mounts, is not deploy the pod, because if I do it and it starts and then it
The problem is all these
suspends,
components,
won't that cause ugly things to happen and potentially avalanche throughout Kubernetes?
meaning if the Cube API is hitting limits,
Yeah.
I mean your pod just doesn't get scheduled. I mean, if it gets scheduled, it just doesn't start. It remains pending.
Yeah, well, what happens then when it remains pending? Will that actually be determined to be a failure that would try to redeploy it again somewhere else, or would that just sit there indefinitely?
No, it just sits there indefinitely. It's just trying to start the pod.
It'll give up after a while, right?
It'll get back off. It won't get rescheduled.
No, it'll keep backing off until it quits backing off.
Yeah, it'll back off. So I run into this all the time.
Yeah.
But yeah, it'll back off for a while until it hits your timeout, and it'll finally give up, and then it'll try it again.
Yeah.
Does it retry indefinitely?
Yeah,
Okay.
well, unless you change the setting in your spec and tell it not to. It will.
Yeah.
Okay.
It's back off and retry. I think our max back off is like 2 minutes right now. It'll do exponential back off up to 2 minutes, and then after 2 minutes it'll try.
Doesn't hurt.
Okay. So any other remarks on this issue? I think we're going to solve it through documentation and small bite-sized chunks.
I think sound provisioner just our limited tool size of
Yeah, I'd be satisfied with just cleaning up the high process. Is the big problem.
All right. So should we move on to the external provisioner or external storage?
Yeah, if you want to stop the recording and then start so that we can do the videos and